Sir has an impressive publication record about 230 publications, and more than 50 publications are in Q1, uh, national international journals. Has a citation of 8,250 plus, and has an H index 56 and I10 index 174, and has an H index of 50 in Scopus. This record shows his popularity in the field of specialization. Nearly 25 reputed international journals and 15 Indian research collaborations with him. As a PhD guide in the field of research, he had guided, supervised and mentored 5 students and facilitated the journey of research. Currently, he is supervising 4 students. Moreover, he is editorial board member for 7 reputed journals and also reviewer for journals of higher reputed journals like Elsewhere, Spinjo, ASME, Emerald and many other publications. Recently, he wrote a textbook on advanced differential equation and it became more popular book for the postgraduate students. He also chaired, delivered invited talks at various national and international conferences. Some awards and recognitions in his career. The seed money for young scientists for research from Vision Group on Science and Technology, Government of Karnataka in 2014, included as recently published list of 2 percentile most widely cited scientists in different disciplines for second time. The world's top 2 percentile scientists by Stanford University received the VGST award for research publications in 2021 in the field of computational and mathematical sciences by Government of Karnataka, Vision Group on Science and Technology. 5 papers have been recognized as top cited articles in 2021 in Heat Transfer, ZAMP, Journal of Applied Mathematics and Mechanics, Numerical Methods for Partial Differential Equation by Wiley Publications. Sir, now over to you, sir.
Okay, thank you, Manju. So, today I am giving lecturing on application of clique polynomial and neural network concept. So, application here I am dealing with. When I am not comfortable, I will take. Because this is comfortable for me. See? Am I audible? Okay, fine. See, I am doing majorly research on fluid mechanics, but today I am dealing with a solid mechanic problem. And recently I attended a workshop as a resource person at NIT Arunachal Pradesh, and I think many of you know, now artificial intelligence is a part of all curricula. So whether you go for engineering or even medicine, now artificial intelligence is must for all. So I will use this. Now I will use the technique of artificial intelligence. There is a part of artificial intelligence, that is a neural network technique I will apply. And also, some of you may be interested in graph theory. I am applying graph theory technique to solve ordinary differential equation arising in solid mechanics problems. Fine. So next. So it is my bounden duty to remember my guide. He is my guide who given exposure to the field of mathematics, Professor C.S. Bhagyawadi. He is a retired professor from Coimbatore University. Presently he is a UGC Emeritus Professor, and very few are recognized as UGC Emeritus Professor, and my guide is one among them. And I am very proud, and he is doing field, you see, the many fields he is doing the research, not only in the he is the one of the active researcher in most of the fields. See, applied mathematics, pure mathematics, even in computer science, he guided a student. This is the one of his greatness, and always I feel proud to be his student. So outline of my lecturing. So graph theory, I am not an expert of graph theory. So I am doing research in the fluid mechanics and solid mechanics, but now I am using one of the graph theory technique to solve the problems, and I will give some last students. Listen carefully. See, as madam told, some may not be 100% useful for your career, and we know 100% definitely it is impossible and it is not realistic. At least 1-2% if you impressed, if you instigated, that is enough for us. So, okay, please you don't disturb others. You listen carefully, because some of you think, some of your words, if you got an exposure, that is more than enough. I will tell you my story, how I did a research later, if time permits. See, everything happens in the conferences. You are very fortunate. Your teachers have organized the conference. Now it is a rare opportunity. So many institutions are not organizing conferences at all because of the time. That is a finance constraints. You are fortunate. You use this opportunity. Okay. See, I am explaining graph theory concept, artificial intelligence, and in the graph theory I am using click polynomial method, and artificial intelligence I am using in physics informed neural network. So many neural network you may be heard, artificial neural network, back propagated neural network, like that some of the terms you may be heard of it. And you see the those who are doing research in the field of graph theory, we are open to collaborate, because there are so many methods are there. So one of the method is this click polynomial method. Many polynomials you are studying, graph theory researchers, and we are expert in analyzing the particularly whenever we go for a polynomial solution, the problem is convergency. But we are equipped with that one of the good method called a Pede approximant. By using that Pede approximant, we are able to get a most convergent solution, and the problem of that convergency can be solved very easily. That's the thing we have with us. And if we are expert in some other polynomials method, definitely we are open to collaborate, and definitely we can solve some of the problems. Even my colleague, he solved a fluid mechanics problem with the click polynomial method, so it is very useful. Of course, later we can discuss what is the percentage of its accuracy and what is its applications and other things also with respect to click polynomial. Okay, so two things I will concentrate. One is which I am expert, another which I started to study. Okay, so next. So just to create an interest, so I am not going in detail, and many of you already studied, even some of the degree students are also knowing the concept of graphs. Next, you know what is this and edges. Next, see, I want a definition of two things. One is directed graph and undirected graph, and the present concept is on these two concepts only. So these are the example, complete graph. So I am using the concept of this complete graph, a graph in which every pair of vertices is joined exactly once. This is a complete graph. This concept is very much useful for now. And this is some of the applications. Okay, next. Fine. So why I have given these 3-4 slides for you? This is the things which you know. Just you remember the things, recall it, then I will apply the concept, and easily you can follow it. So I want only two things: directed graph, undirected graphs, complete graphs, connected graphs. Only these 4 basic concepts I required, and other things I will explain in detail when I come for the particular problem. I will take a particular example, and I will explain how the concept of this click polynomial is a pure mathematics. How I am using to solve the problems of solid mechanics. Okay, so fine. So now I will go for the artificial intelligence method. See, many of you know what is artificial intelligence. So it works based on our neurons, just our neural system. You know how our things are happening in our body. It's all because of neurons. See, this is the thing. So these are all the subsets. So the big set is artificial intelligence. In the artificial intelligence, machine learning will come, and even deep learning, neural network, artificial intelligence, other thing. This is a small case of this big artificial intelligence. Neural network is a small set. Artificial intelligence is a big one. And deep learning, machine learning, these are all some cases of artificial intelligence. You may heard. So particularly this deep learning and machine learning, now the mechanical people, the engineers are using widely. And even we are using machine learning technique to solve some of the solid mechanics problems. And we are getting good result. When see, particularly after the advancement of computers, with the techniques of artificial intelligence, we can do wonders. Many things as a mathematician which I required 2-3 days, even with computers, can be solved within a minute, within an hour. Even minute is sufficient to get it trained. So I will explain later how these techniques are helping us, and how these and one thing as a student you remember, next coming days are only with artificial intelligence. Those who are regular readers, regularly if you are watching the current scenario, you must be knowing. See, now the future is only with artificial intelligence. If you don't know the artificial intelligence, there is no life. Whether you are a mathematician or an engineer, whoever you may be. But artificial intelligence is must. Now I mean some part of artificial intelligence. Okay? Okay, next. Next. Okay, this is the thing. This is what it is happening in your mind. I am not going to explain in detail. So this is the in our brain, everything will not happen at the same place. So particular part of the brain will operate like this. Next. You come for next. Yes. So this is what working biological neurosystem. How our neurosystem works. So this is the way. So it has this type of, these are two neurons I have considered. So axon of, madam, do you have pointer? Okay, no problem. No problem. See, so this is an electrical signal between the two neurons I am considering, and these are the two parts. And the main concept is axon. So you say the axon in between. In between the two neurons there is an axon, and it plays an important role. Yes, madam. So this is the thing. Around 100 billion neurons are there in our body, and with the help of neurons only we are communicating. Yes, you go for the next. Fine. So this is now what the mathematics is. Okay. Up to that, biological things I have explained. Now I will come to the for the actual mathematics. I converted a biological to the neurons. This is what happening. See, dendrites. This is the input. Dendrites are the input, and I have wrote here x0 is equal to 1, x1, x2, so on, xn are the input. This is just like a dendrites. So anything if we touch the heart body, that message should go to our brain through the neurons. That heart body, the input, will be taken from the neurons from dendrites. Dendrites is nothing but our inputs. And all the inputs, whatever we are getting, should goes to a nucleus of that neuron. And this nucleus is nothing but our function. That means the process which you are going to operate. That we say hidden layer. Later I will explain what are the different parts of this artificial neural network. And it comes, neuron is parallel to our linear function and activative function. That is nothing but the hidden layer. And it transfer to another. And this type of many neurons. And we say axons we will construct. And the process will be like this. Just I have converted the biological system into mathematical way. Means artificial neural network I have explained. Next one. Fine. So this is the thing. See. So this is what it happens. This is artificial neuron. We say perceptron. Perceptron is a biological word. So when we go inputs, x1, x0 is equal to 1. There is a first input. Corresponding value is b. This is important. The first input is very important. Parallel to our initial condition, y0 is y of 0 is equal to y0. Y of 1, y1. So like that, the first condition is important here. That is x0, input is x0 is equal to 1, and that is equal to b. And similarly, x1, x2, xn, so are the inputs. And B, W1, W2, Wn, we said is a weight functions. These are the weight functions. So, and when it combined with these inputs with the weight function, it goes to our artificial neurons. This always artificial neurons will be in the hidden layer. And it calculates linear function and activation function. Linear function we have to choose depending on a input data. Okay. So before starting this mathematical part of this artificial neural network, let me give some facts about the artificial neural networks. See, this is not an independent method. So whenever the problem arises in mathematics, we solve in the different ways. One is a numerical method, analytical method, semi-analytical method. You know that how we will solve. When it is a problem is a complicated, we will go for the numerical method. But this artificial neural network is not comes in any of these category. This is not an independent method. So this is just a data-driven techniques. Input we want. Later I will explain how we will train the data. So input we want. But one thing you remember, this is not an independent method. It is a data-driven techniques. If your input data should be taken. It should be extracted from one of the numerical method or even exact also okay. But data should be extracted. The data output of ANN, artificial neural network. If I say ANN, it is understood ANN, artificial neural network. So this output of ANN purely depends on your input data, and input data quality must be good. And this input data, we will get it from one of the numerical method or the exact method. Based on input data, we will train the machine and we will get an output, and for our desired values, we can extend it. That is different. But this is not an independent method. We want input from one of the numerical method or the exact method. See here. These inputs are this x0, x1, x2, xn. So these are all inputs which we get it from one of the other numerical method. And of course, these are the weight functions and linear function you have to choose. Later I will explain what are the different type of functions are available to choose, and output we will get it. So now the recent advancement is the 10 times better than ANN is physics informed neural network. We are using physics. So actually this just like an input method, and we are using a physics informed neural network. It is quite different and quite helpful. Later I will explain what are the advantages of PIN versus ANN. Okay. So next. See, this is the thing. I have explained already. Output is Y. Output is Y, and W1 X1. X1 is the input, W1 is the weight function, W1 X1, W2 X2 and so on, plus B. B is the first input. So therefore Y is equal to B plus summation of W1 into Xn. So I have expressed in terms of summation of the function, mathematical, to explain the mathematical part. Okay, next. So, okay, next. Okay, fine. See now. Here, now the mathematics part has come. Before that, you need to know something about how it works. But this is only with ANN. All these concepts are required only for the ANN. Now the most advanced PIN has come. For the PIN, means physics informed neural network. These are the things are not required. It will take automatically. That I will explain later. See, these are the functions, transfer functions, and the mathematical expression. You know the function. And in most of the cases, we use Gaussian function. These functions we have to choose based on your input data, and you know what type of problem you have. For example, if you are taking nonlinear problem, it is coupled, and even boundary conditions are also nonlinear, then you have to choose a function in such a way that your input is equal to output. So as already I have told, you should have a ready-made data with you. So that data, you have to give input, you have to train, and you have to verify. These are some of the steps of ANN. Okay. See, these functions should be taken to minimize the loss function. Later, I think I have skipped that method. Loss function also will come. Loss function will minimize the error. You know how to control the error. This loss function will control the error. So to control the error, this type of linear function, transfer function, we said transfer function, it may be linear or non-linear. This function has to be chosen in appropriate way. Next. Okay, fine. Now I come for the PIN. So physics informed neural network. So whatever the things I have told about ANN, but to get the input from the ANN, many input data, thousands of input data we require to train the machine. So once the machine is trained for our input data, it should be verified, should be checked for its validity. Validation also should be done with the ready-made data. So input data, check, validation. Then only we can go for our desired output. But all these things, there are so many difficulties, practical difficulties will come, particularly getting the input data. If the problem itself is a nonlinear, problem itself a coupled, then solving itself is a challenging one. Its solving is not an easy. So if you are able to solve those things with a desired accuracy with numerical method, then there is no question of using ANN. But if you are not solving with the desired accuracy, we are not able to get input data for the up to desired accuracy, then this is also not useful. Are you following? See, this method is helpful only when you have a data, but with desired accuracy. If it is not with desired accuracy, output will be corrupted. Output it will contain an error. Of course, we have so many methods are there. I am telling all these things with respect to ANN. But now it is a PNN, physics informed neural network. It is it understands the physics. So in the ANN, we don't know what is the data. It will take only data. It will train we will train the machine. Even the machine will not know whether it is a fluid mechanics problem, solid mechanics problem, or a population problem. Simply it will give whatever the training we give to it. But physics informed neural network is not like that. It follows the physics laws, physics law of cooling, heating, whatever the laws associated with problems. First you have to choose fluid problems. Yes, it will take the all fluid flow rules, it will follow. That's why we say physics informed neural network. It follows the laws and no need to verify, no need to ensure that it follows. See, the advantage is you required very less data when compared to ANN. There are thousands of data is required to train the machine, but here that is not the problem. You required very less, 100 data is more than sufficient. And even if it is, and one more thing is, your input data is maybe may not be of desired accuracy, it's okay, no problem, because it adjusts the value with respect to physics. If you are not choosing physics properly, it will not. But of course, it is very easy to choose in the machine. So these are the things. See, what are the procedures to solve? I am explaining just how to solve the ODE. So first, initialization. If your problem is in second order with initial condition, there is no question of initialization. But if it is not that, if it is a fluid problem, it is a coupled, you have to make you have to convert all the problems to initial value problems. That initialization has to be done. That's the first step. Then data collection with respect to that, by known method of numerical method, you have to collect the data. After collecting the data, define collocation points and formal loss function. I have told loss function. Here, loss function it will be adjusted with physics informed. But in ANN, loss function has to be chosen. Loss function, to make it effective, you have to choose the linear function. But here that problem is not there. So then, training, forward and solution. Training has to be done, and I have already told, against ANN, PIN is not required much training, because it doesn't require much input data. That's why training is also required less time. Next. So these are the steps I have explained. So 1 minute. Previous. So few things I will explain. See, physics laws, data fitting laws, collocation laws. These are the three major points which influences on the quality of our output. So if you concentrate on these three, so physics laws express the PDE, boundary and initial condition, as a loss term. If you concentrate on these three terms properly, then we will get even 10 to the power minus 6 accurate solution. Yes. Next. Okay, fine. See, these are the advantages of PIN in solving ODEs and PDEs. Okay, go for next. I have told data driven models. 1 minute. So I told already these all artificial neural network methods in mathematics or in engineering, all are data driven. So we require data, proper data, error-free data. So, but advantages of PIN is we required very less data. I have explained everything. So data required, PIN requires less data for training due to incorporation of physics-driven constraints, whereas ANN it does not have that facility. Therefore, we required more data. Go for the next one. Okay, fine. So this is about physics, ANN. Now I will come for the click, because now I am going to give an example where that problem was solved by differential transformation technique. The same problem I will solve with the click polynomial technique. The same problem I will solve by ANN as well as PIN. The solved problem, one of the research problem, with 4 different techniques I have solved, and all the 4 methods it was published. All the 4 methods now I am going to explain, except the first, which is very obvious, differential transformation method. That too, many differential transformation methods are there. One of that alpha parameterized differential transformation method I applied, and even my students they applied reduced differential transformation also. But one advantage with us is we know the PED approximant. With that we will get an accurate convergent solution. Of course, the same problem I will apply ANN. Already I have explained ANN. Now I am going to explain click polynomial method. Both the method I will apply for the same problem and we can compare it. Is it okay? Fine. So wait. So click already I have explained what are the requirements. I require directed graph, undirected graphs, complete graphs, connected graphs. Only these 4 concepts I require. Even I am not from graph theory. Even except these 4, I don't know other definitions also. Frankly telling, even if you say, give me one more example over this, I will struggle. But the next process is with respect to a polynomial. That part I know very well. That I will explain now. Scope. So this click polynomial, electrical engineering, even chemistry, they are also using. Now I am applying this click polynomial method for the solid mechanics problem. So quite obviously you can use it. So why I am choosing this particular method, you are all youngsters and not difficult to understand the basics. Now you can follow it. Later I will explain. In the similar fashion, if you observed any other polynomial methods, you are open to discuss with us, because